another customer success VMware Cloud on AWS webinar. This is a continuation of our webinar series. Today, our topic is going to be VMware Cloud on AWS Troubleshooting Guide. A few housekeeping reminders for those that have joined via Zoom. You are muted. Please put your questions in the Q&A box. If you have any, we'll try to leave some time at the end for questions as well. If you're watching this on Twitch, feel free to put any questions in chat there, and we'll get to them as well. We definitely want to make this as interactive as possible, so feel free at any time to ask any questions, and we will answer them. Today we have an esteemed guest, my Vegas buddy, Mohit Singh. Mohit, do you want to give yourself a brief introduction?
Hey everyone, this is Mohit and I'm a cloud services engineer at VMware. You would probably would have seen me in chat, and my team is responsible for helping out customers with troubleshooting issues with VMware Cloud and AWS and other cloud services as well.
Excellent. Yes. So the chat he was referring to was a support chat within VMware Cloud. He's
Yes.
been with us since the beginning, so he has extensive knowledge in this area. So take it away whenever you're ready with your presentation.
Okay, thank you. So, guys, today I'm going to walk you through some troubleshooting techniques which will help you fix some common issues on VMware Cloud and AWS. These are the topics which we will be covering today. So, let's dive right in. So, let's start with HLM or hybrid link mode. HLM allows you to link your VMware Cloud and AWS vCenter server instance with an on premises vCenter single sign on domain. You have two options for configuring HLM, and it is very important to note that you can only use one of these options at a time. So one is HLM through Cloud Gateway Appliance, and the other is linking from your Cloud SDDC. So prerequisites for HLM can be divided into three parts. First is the common prerequisites. These are common to both linking from the Cloud Gateway Appliance and from the Cloud SDDC. Second is prerequisites when linking with Cloud Gateway Appliance, and the third is prerequisites when linking from the Cloud SDDC. So if you take care of these prereqs and ensure that everything mentioned here is taken care of, it is unlikely you will face any issues. So first we'll talk about the common prereqs. So NTP is one of the most important ones here. So ensure that your on-prem data center is synchronized to an NTP service or any authoritative time source. HLM can only tolerate a time skew of up to 10 minutes between the on-prem data center and the cloud SDDC. Then you need a VPN or a direct connect to connect your on-prem network to the cloud management network. The maximum latency between this connection can be 100 milliseconds round trip. You need to decide which of your on-premises users you want to grant cloud administrator permissions to. Add these users to an AD group within your identity source and ensure that this AD group has access to your on-premises vCenter environment as well. You need to add your on-prem AD as an identity source. In order to do so, ensure that you have login credentials for a user who has minimum of read-only access to the base DN for users and groups. Then your on-premises DNS should be able to resolve the Cloud vCenter FQDN and also other on-premises management components like the PSC, domain controller, and so on. Set the Cloud vCenter FQDN to resolve on the private IP. This IP should be reachable over the VPN or direct connect that exists between the on-prem DC and the cloud SDDC. A couple of slides later, we'll discover the necessary ports which needs to be allowed on the on-prem firewall and the management gateway firewall for this SDDC. So we have already covered the common prereqs. Now we'll cover prereqs for linking with Cloud Gateway Appliance. So NTP is the one which is already covered, but what you need to ensure is that there is a time sync between the machine from which you plan to run the installer. So say you are running the installer from a Windows machine, even that machine needs to have its time synced uh, with the PSC or the vCenter at the on premises. Your on premises environment should be running vSphere 6.5 patch D or later. You can only link one on premises or domain and one cloud SDDC. So it's one-to-one mapping. In case you have enhanced link mode at your on-prem, that will work as well. But it's essentially just one-to-one mapping of an SSO domain. You cannot have multiple SSO domains there. Ensure that your on-premises PSC is configured to use HTTPS port 443. If it is configured to use any other port, maybe you chose a custom port during deployment of the PSC, the Cloud Gateway appliance deployment will not work. Verify the host on which you intend to install the Cloud Gateway appliance meets the following hardware requirements. So the prereqs for linking from Cloud SDDC. I think this is self-explanatory. We need to ensure the on-prem version matches one of these two criterias. So now we'll look at the port diagram when linking from Cloud SDDC. Many times we see issues, maybe it's the documents are not very easy to consume. The customers are not sure which ports need to be allowed and how is the communication happening. So this port diagram can be used as a reference, and the ports on your on-prem firewall can be uh, allowed accordingly.
So we just had a question pop in real quick, Mohit. Is vSphere 6.7 supported in these scenarios?
Yes. So as I said, 6.5 and later, so 6.7 currently is.
Okay, thank you. Go ahead.
So next is the port diagram when we are linking with the Cloud Gateway appliance. So Cloud Gateway appliance is an appliance which we deploy at the on-premises, and it interacts with your on-premises vSphere components. You can see the ports on which it is talking to the on-prem components, and then only port 443 outbound is needed from the Cloud Gateway appliance. So you can see that the Cloud Gateway appliance here talks to the Cloud vCenter on 443, and also uh, on 902 to the Cloud ESXi. Now this is not required, 902 is not required for HLM per se. It is only required if you want to open up the VM console from the Cloud Gateway Appliance UI. Otherwise, you won't be able to open the VM console if 902 is not allowed. So that's why 443 and 902. So you need to set your on-prem DNS server IP under management gateway here. You can see DNS server 1 and DNS server 2. This is a screenshot from my lab, and I only have one DNS in my lab, so you only see one IP there. So normally, customers would have, for redundancy purpose, they would have multiple DNS servers. So you can put two of them here. And if you have multiple DNS, ensure they are exactly identical. So when you input your DNS server IP in here, this will allow the management gateway, the cloud ESXi host, and other cloud management VMs to resolve fully qualified domain names on the management network. You must specify the IP address of at least one DNS server here. If you and do not forget to allow port 53 on your on-prem firewall to allow these DNS queries to pass through. So, there are two parts. So one is your on-prem firewall and the other is the gateway firewall on the SDDC. So the gateway firewall on the SDDC already has this port allowed. So you don't need to go ahead and do that from the SDDC side at least, but on the on-prem firewall, you still need to do that. Another important thing to note before you initiate HLM is to set your vCenter Cloud FQDN to resolve on the private IP. So if you see this here, there's an edit button here which is not there in the screenshot. You can set the vCenter to resolve on the private IP, which would be accessible over VPN or a direct connect. So this is a sample configuration of how the management gateway firewall rules will look like. So in this screenshot, you see this is what I have in my lab STDC, and it's very simple here. So on-prem, you see destination here as on-prem. So on-prem is a management group I created, which represents my on-premises network. So this group can be created from the VMC console in the network and security tab. So you can see HLM outbound and HLM inbound. So on premises is my network at the management network at on prem, and as you can see, only these ports are allowed. So SSO TCP 7444 is only for backward compatibility with 5.1 and 5.5, I think. We are having a discussion internally to, if this is not required, we can get rid of it. So the most important port you see here is the HTTPS port 443. So assuming you have all the prereqs taken care of, and you have ensured you have followed each one of them, and still for some reason you do not HLM linking is not working. So what you can do is you can use this VMC connectivity checker. This is available in the cloud console. So you need to go to the SDDC view, then the troubleshooting tab, uh, then there's a use case. In the use case, there's a drop down. So you have to select HLM and then input your details. So the details will include your on-prem DNS server, your on-prem vCenter, the PSC, your Active Directory. So this would be one of your domain controller servers and one of your ESXi. And one thing to notice, this is most useful when you're doing HLM linking via Cloud SDDC, because it will only check connection from the cloud to the on-prem, not the other way around. So this is one thing you can do. In case everything is fine, uh, if you like from the connectivity checker, if everything's fine, what you can do is you can test network connectivity the other way around, that is from on-prem to the cloud. So this is most useful when you're doing HLM linking via Cloud Gateway Appliance. And if the linking fails with an error, something like could not reach the target SSO domain, check your VPN and DNS configuration in the VM console. These are few of the commands which you can run from your Cloud Gateway appliance. And if any of the above test fails, it is most likely a firewall or a network configuration issue. So you can SSH into the Cloud Gateway appliance. You can try ping or an NS lookup to the Cloud vCenter, and then you can test the network connectivity on port 443. The other two are basically like scripts. Uh, you do not need to understand really what values it is returning. You just need to see if it shouldn't hang. It should just return some values. If it is returning some values, that means the communication is happening fine and there's no network problem there. So these are the logs which you can see on the Cloud Gateway appliance. So assuming you have ensured all network communication is healthy, and in case HLM linking is still failing, you can go through these log files mentioned here. This is only relevant to the case when HLM is being done via the Cloud Gateway appliance. In case you are doing HLM via Cloud SDDC, the customers do not have access to the logs. So you need to raise out an SR with us, or maybe reach out to us via the support chat option we have in the Cloud Console. So the most important log file we are looking here is the HPC-SVCS log. This will have any um, link. So if you have link failures, not able to link your on-prem to the cloud, you will find all the errors here. So any questions for HLM?
I haven't seen any come in so far. Again, everybody could feel free to post any questions in the Q&A box, or if you're watching via Twitch in the chat box. I'll bring up any as they go along, but it looks like there's none right now. So I just want to emphasize how many times, and I'm sure Mohit, you can echo this. Basic things like the DNS or the firewall have
Yeah,
prevented this from working. So uh, make sure you kind of rewatch that part when you're kind of configuring some of this and follow along, because that's led to quite a few chats, I'm sure.
right, right. So the mostly the cloud side is always taken care of. It is always, almost always, the network connection to the on-prem network. So if you go through the previous slides, and if you take care take care of all of them, you won't find any issues with HLM. So I'll start with VMware Site Recovery. So VMware Site Recovery is a business continuity and disaster recovery solution that helps you to plan, test, and run recovery of virtual machines. And you can keep the on-prem vCenter server as the protected side, and the cloud vCenter server as the DR side, and also the vice versa as possible.
Just an important point to mention there is that if you do vice versa, you will pay egress charges out of AWS. And you can
Mhm.
also do SDDC to SDDC protection as well.
Right. Thank you, Matt. So as we saw with HLM, the first step to troubleshoot site recovery issues is to ensure that the prereqs have been taken care of. This list here is not a comprehensive list because there were like many points and I couldn't fit them all of them here. You can check our documentation for all of them, but what I have here is the most important and the most common ones, which we don't see, we see issues with, and that is why your SRM site pairing or your application might fail. So I'll start with the first one. So you'll see issues if you install SRM server before you install the vSphere application server in your environment. So always ensure that you do VR first and then SRM. VR and SRM version 8.1 should be used. I think 8.0 works as well, but it is best to use the latest one. You can check the compatibility matrix there to check what version of SRM and VR is compatible uh, with the PSC or the vCenter versions. If you're running the PSC, the vCenter server, the Site Recovery Manager server, and the and the VR server as a virtual machine, you need to set up NTP time synchronization on the ASXI host on which the virtual machine runs, and then set these appliances to sync their time from the ASXI host. Time skew problems are most prevalent because SRM server will be installed in a Windows machine, and most Windows machines sync their time from the domain controller. So essentially, then you would have two different time sources. That is why it is best to let your ESXi host sync its time from an NTP source, and all the other VMs should sync their time from the ESXi host. I have a network port diagram for site recovery, which can be referenced to allow ports on the firewall. We'll see that port diagram after a couple of slides. One last point to note is that the cloud VR and the SRM server only have a private IP. That is, they cannot be accessed from the internet like the cloud vCenter. So in order for you to do site peering, VM protection, and other DR related tasks, you need to have a VPN or a direct connect to the SDDC. Only then can you open up the SRM console and do any DR related tasks. These are some recommendations which should be adhered to. Try and keep default settings wherever possible. This will minimize complexity and make troubleshooting easier if something goes wrong. Before you can protect VMs with site recovery, you will need to create network mappings, folder mappings, resource mappings, etc. And it will be better if you use a consistent naming convention. So these are not, a mandate, but just some recommendations from our side. So this is the port diagram I was referring to. It includes all the necessary ports, and it also tells you which component on the cloud side is talking to which component on the on-premises data center. Accordingly, you can create firewall rules on your on-premises firewall. In the subsequent slides, we'll see how easy it is to create firewall rules on the cloud SDDC.
It's really not as complicated as that slide looks it makes it out to be, I don't think.
Yeah, the SDC side is very easy. Just uh, what you need to take care of is the on-premises firewall. So you need to set your on-prem DNS server IP under management gateway. This is something similar to what we did with HLM. So the cloud management components will forward DNS queries to this DNS server to resolve the on-prem FQDNs. And for the other way around, primarily the cloud side, vCenter, the cloud SRM, and the cloud VR has to resolve by the on-prem components. Host records for these are set in the DYN DNS service. So if your on-prem DNS server is capable of resolving public FQDNs, it should automatically be able to resolve these host records. In case your on-prem DNS server cannot resolve these public host records, what you can do is you can create a DNS zone for VMware vmc.com in your on-premises DNS server. But before you go ahead and do any site pairing or anything like that, ensure that you have the host records created or your DNS server is able to resolve the public FQDNs. So this is how the firewall rules for SRM looks like on the cloud SDDC. You see, it is very simple, not as difficult as it might look from the port diagram we saw earlier.
Just as well, we are still working and plan to put in the firewall rules accelerator. We did have that in our NSXV version of the portal, and we're looking at putting that into the T version to even further simplify it. But this is the step that's required now.
Right. So vSphere application and site recovery manager, what you see in source here is, uh, system defined groups. It it contains the um, it contains the IP addresses of the VR server and the SRM server, and then you see services like VMware Site Recovery vSphere application and VMware Site Recovery SRM. These include all the ports you see here. So for SRM, it will include 9086, and for VR, it would include all these four ports. So earlier we had to include all these ports manually. So now what we we have done is with just one service, all the ports you saw there would be included in the firewall.
And just apologize if you mentioned this, but so those
Mhm.
services are predefined by us, so they're success just a drop down option for
Yeah.
the services.
So we can also use the VMC console connectivity validator to check all the required network connectivity from your VMC SDDC to the remote site is in place. The remote site can be on premises or another VMware Cloud on AWS SDDC. So you are required to input few parameters like the on-prem PSC, the vCenter, the SRM, and the VR server, and then you can click on run all tests. The status of each test is displayed as it runs. When a test has finished, you can expand the result to see the details of the test results. The goal is for all of these tests to pass. In the screenshot, I can see that connectivity from the cloud VR to on-prem VR, which is on a VR server on my on-prem. Uh, Connectivity on port 8043 is failing. Now, once I have found that, I can now check the network settings on my on-prem and the firewall settings to see why or what has not been set up properly. So once you have rectified that, you can go ahead and run these tests again. And if you see all of these tests pass, then you can go ahead and do the site pairing and the other DR related tasks. So the connectivity checker uh, would only verify connectivity from the cloud to the on-prem and not the other way around. So to check network connectivity from on-prem to the cloud, you need to log in into your on-prem SRM server, your vSphere application server, and your vCenter, and then run these commands to verify port connectivity. So I have these two commands can be used, OpenSSL and Telnet for Windows Server. And you can use the network port diagram as a reference and then test out all those connectivities. So as with HLM, you would only have logs access to on-prem because the cloud side is managed by VMware, and customers do not have access to the management components and also to the management logs. So in an event you have verified all prereqs have been taken care of, all network communication is healthy, and if you still see issues, these are the important log files you can check. So HMS logs would have like replication management related error messages, and HBR log would have issues with when you have like replication not happening, RPO, uh, the RPO wasn't met, and all those errors will be logged in this HBR log file. So any questions for DR as a service or site recovery?
Nothing currently in the chat. Again, just anybody has any kind of questions, even comments, feel free to post them. But as of right now, no, there are not.
Okay, so I'll move to the next slide. So let's talk about VPN now. We have two types of VPN that we use with VMC. So one is the L2 VPN. With L2 VPN, you can stretch multiple VLAN based logical networks across geographical sites. And then the other is L3 VPN. It is used to connect routed networks uh, from the on-premises network to the networks in your SDDC. So we'll start with L2 VPN. We have a very nice step-by-step guide on how to create in L2 VPN from for VMC SDTC. This is a feature walkthrough which has screenshots along with additional notes which describe the steps being carried out. If you follow all these steps as mentioned, it is unlikely that you would face any issues later. However, there are some caveats that I would like to point out. I have seen customers trying to extend VXLAN based networks without realizing that it is not supported with PMC. So make sure you're not trying to extend any VXLAN based networks uh, via the standalone edge client. Apart from configuring L2 VPN client and server, there's a third important step which is often missed. Without doing this, the tunnels won't come up. You need to create an extended network on the VMC Cloud console and assign it a tunnel ID that has been mapped to the VLAN network which is being stretched.
All right. Well, hey, we have a question come in. For L2 VPN, do we need a virtual appliance in on-prem?
Yes. So for network stretching, you need to deploy a standalone edge client on your on-premises, and through that, and it will serve as a L2 VPN client. VMC SDDC will serve as the L2 VPN server, and that is how you would be able to stretch VLAN-based networks from your on-prem to the cloud.
And to be clear, this is particular to the L2 VPN. HCX does its own thing, which I think you'll probably be covering a little bit later. Um,
Yes, so
yeah,
yes, so since we had 1 hour and we had so much to cover, I did not include HCX because it in itself is pretty huge.
yeah. Maybe we'll
So
do that next
we can do
webinar.
one later.
Yeah,
Yes,
we always need new content as well. But so yes, so this is for the I guess lack of a better term, the native L2 VPN that's built into VMC. HCX is a separate thing, and there is a follow-on question about so NSX on-prem is not required. No, it is not. You just need the standalone Edge, which you can get for free. You can download the appliance. So
yes. And we are not covering HCX here, but with HCX, um, you can even extend VXLAN based networks. So with the native L2 VPN client, only VLAN networks are possible. So this is the L2 VPN topology diagram. Um it will help you understand the packet flow across the layer 2 tunnel, and in case packet captures are needed during troubleshooting session, you would know the reference points. If you notice the standalone edge on the left hand side, which signifies the on-prem network, the edge gateway has three VNICs. One of them is not shown in the diagram. First is public interface, which maps to the uplink port group. Uplink port group is a distributed port group created with a single VLAN ID. Second is the trunk interface, which maps to the trunk port group. It is VNIC 1 here. So a trunk port group is a distributed port group created with multiple VLAN IDs or a range of VLAN IDs. The third NIC, which we haven't mentioned here, is for HA. Another thing I would like to call out here is the trunk port group needs to be configured in a slightly different way. So one is that the VLAN type should be set as VLAN trunking, and you need to specify the VLAN range. So it would include all the VLAN IDs that you want to stretch from your on-prem to the cloud. So say you have maybe 10 VLANs starting from 100 to 110. So you can put your VLAN range as 100-110. And then the other thing is forge transmit should be allowed on the port group. This is the trunk port group I'm talking about. And then the third very important point here is that sync port needs to be configured on the VDS. In the later slides, I will tell you how you can do that. So if you have L2 VPN issues, the first thing to do is to check the tunnel status on the VMC console. If it shows as down, you can check the error messages by clicking on the I pop-up of the status section. Once you click on the I, it will give you an error message which is intended to help the reader identify errors due to misconfiguration of their end of the VPN. If this tunnel status is down, it is important that you check port 500 and 4500 are open, and also IPsec with protocol 50 is allowed on your on-premises firewall. So since this L2 VPN is using IPsec, you need to ensure these ports that I mentioned here are allowed on your firewall. So this is only the on-prem firewall I'm talking about. Nothing needs to be done on the cloud SDDC. It is already allowed natively. In case there are no firewall rules blocking IPsec communication, we can check the on-prem edge client for configuration mismatches. I have listed here the most common ones. Of course, there can be many other things that can go wrong, but essentially we have seen these are the most common ones which are missed. So you need to check to see if the sync port is configured or not. You can run this command here on host where the standalone edge is running. If you don't find a sync port configured, you can go ahead and configure it. So peer IP address mismatch or peer code mismatch is the next. If you log in into the standalone edge and run the command show configuration IPsec, you can verify from the output if the peer IP or the peer code mismatch. If it does, you can get the latest peer code from the download config tab in the L2 VPN section of the VMC console. In case the VPN status is up, but there are data path connectivity issues, verify if there are any tunnel ID mismatches. Uh, then you can also verify if the trunk port is uh, the trunk VNIC is assigned to the trunk port group, and if sync port is configured properly or not. So to confirm trunk interface, these are the commands you can run. So you can log in into the standalone Edge client and run show service L2 VPN trunk table. In the output, the interface for which the trunk flag is one is the trunk interface. So this will so once you've identified that, you can run packet captures on the trunk interface, and you can see maybe say ARP is not being resolved, or if there's a packet drop, so you can run a packet capture on this trunk interface and see what is missing. Normally if you take care of the configuration, it wouldn't come down to taking packet captures, but in case it does, you can keep these commands handy with you. Any questions for L2 VPN?
Nothing that's come across. I just wanted to kind of mention as well when we're talking VPN in our not today's office hours, but last week's office hours. Michael Collis and our team did a great talk around configuring VPNs and a lot of the stuff that's in the interface, which shows routing and a whole bunch of stuff that can also assist in troubleshooting. So I recommend checking that out on our YouTube channel if you have kind of some more questions around the configuration of VPN. But I think yeah, there's no more questions, so keep on keeping on.
Okay. So let's talk about L3 VPN now. There are two types of L3 VPN that are possible with VMC. One is route-based VPN, and the other is policy-based VPN. The general recommendation is to use route-based VPN. Most implementations of policy-based VPN will set up one security association pair per uh, remote local network pair, and one tunnel will be used for each. You need to ensure that your policies must match networks on both ends exactly in order for a given tunnel to come up. If one or more tunnels do not come up, then the VPN will show as partially connected. Crypto settings must match on both ends, or the tunnel will fail to come up. The most common problems with VPN is mismatching configurations. So you need to triple check your settings if your VPN fails to come up. You can get an idea of where the mismatch is based on which phase of, of the VPN failed. The second most common problem with VPN is firewall or NAT. So if your VPN device is behind no NAT firewall, then make sure that UDP port 500 and IP protocol 50 are permitted, inbound and outbound. If your device is behind a NAT firewall, then make sure that UDP 500 and 4500 are permitted inbound and outbound.
Just
So
one,
this is,
just quickly,
yeah,
one other slight caveat to this slide is the route based and policy based is our NSXT based SDDCs, which are our default and which all of our customers are moving to right now. However, if you're an existing customer that's been around for a while, you may be on NSXV and the route based will not be available to you, just in case you're wondering and looking at this slide.
yeah. So once you have configured and saved the VPN settings, a link will appear which allows you to download the configuration for the VPN. Although this configuration is not vendor specific, the information here is extremely helpful for configuring the remote VPN peer since it provides additional details not shown in the UI. So you see this download config which I have circled here. Once you set up the parameters, you need to click here. It will, uh, it would be a text file. You can open it up in Notepad++ or something similar, and then you can set your on-premises VPN accordingly. Almost always, I have seen with VPN issues that there are configuration mismatches. So ensure that the settings exactly match as you see in the config file which you downloaded. Um, there are there were quite a few VPN settings reference, so I did not include them in the slide. Instead, I have given this link here, which summarizes the available SDDC IPsec VPN settings. Some of the settings can be configured and some are static. Use this information to verify that your on-premises VPN solution can be configured to match the one in your SDDC. So choose an on-premises VPN solution that supports all the static settings and any of the configurable settings listed in these tables. So do not forget to go through this link here. It is quite important. So the vast majority of issues with initial setup of IPsec VPN are due to misconfigurations on the remote end, that is the customer end. The following are sample error messages captured from the VMC console, which are intended to help the reader identify the errors. You can click on, so say you see the status as down, you can click on the I button here, and you can see what is the channel status, what is the tunnel status, and depending upon what error message you get, it will give you an idea as to which part of the VPN it failed. So there are three parts to consider: the overall status, the channel status. This is relevant to IKE phase one or initial exchange, um, and then the tunnel status, which is basically phase two. So each tunnel for tunnel status, each tunnel will have an independent status, and for route-based VPN, you will only see a single tunnel, which is 0.0.0.0/0. So this is this table here, which gives possible problems for different channel status and tunnel status. So I'll pause here for a minute and you can uh, just give it a read. So this is just a possible problem since you do not have, you know, we try and make the error messages as self-explanatory as possible. But sometimes, since you do not have the logs on the cloud side, you might need to rely on the uh, log messages on your side of the VPN. That is the VPN endpoint on the customer environment. So one important tip here is if you make changes to the VPN, it is sometimes helpful if you disable and re-enable it. I've seen, it forces the configuration changes to sync in a more timely manner. So for route-based VPN, there is also a BGP component that is required. The status messages for BGP in the VMC console are not very helpful as of yet. But if you see a status of yellow, then it means that there is a problem with establishing a BGP session with the peer. So here are few things that you can check. First is verify the local ASN setting in the SDDC matches. The second is the remote peers BGP neighbor configuration. Verify that the remote ASN setting in the SDDC is correct, and verify that the remote peers BGP neighbor is using the SDDC's virtual tunnel interface address. If we do not have any questions for L3 VPN, I'll move to Direct Connect.
I don't see any, so I think you can go ahead.
Okay. So for Direct Connect, there isn't a lot that you can troubleshoot from VMC perspective, since most of the configuration is done on the customer's AWS console and the peer DX router at the customer on premises. So there aren't any log messages or any error messages which show up in the VMC console. However, there are a couple of common issues that I have identified, and I will talk about them in the next slide. So Direct Connect configuration is very straightforward from the AWS console. Uh, while creating a private WIF for the VMC SDDC, there is a step where you have to provide the virtual interface owner. Many times I've seen customers, they tend to enter their own AWS account ID here. Instead, what we need to do is we need to input the AWS account ID for your VMC AWS account. This ID is displayed under the Direct Connect section of the networking tab of your SDDC. So when you create private WIFs, you see in here, you see virtual interface owner. So you need to specify which AWS account will own this WIF. So you need to put in the VMC shadow account ID here and not your own AWS account ID. Second, most common direct connect uh, issue I have seen is, so when you create private BIFs, which is to be used by the VMC shadow account, there's an option wherein you click, wherein you check auto generate peer IPs. If you see here, normally by default it is checked, so most customers just leave it like that. There's a issue with VMC currently, wherein it will generate a Java null point exception. So what you need to do is not use the auto-generated peer IPs. You need to input these IP addresses manually. So you see this red box here. You need to populate these two fields on your own. These were the most common issues I've seen with Direct Connect. As I said earlier, there can be different issues, but VMC perspective, there isn't much which we can do. If if your configuration on the Direct Connect console is fine, and if your on-prem Direct Connect router is configured correctly, there shouldn't be any issues.
Is there any guidance there for what IPs to use for those IP addresses?
I think normally we use the 169 IPs, but I need to check exactly uh, what is the recommendation from AWS here, because this is done on the AWS console. So 169 would work, but I would need to check exactly what is the range, IP range they suggest.
Okay. I don't see any. Oh, we have a question coming in. It's a little bit different topic here. Question out of topic. HCX over Direct Connect using private IP address. What have we seen? Is HCX connected established via public IP address internet and only possible to establish connection via private IP after chat support intervention? So, yes, that is something that we're looking at resolving. So there is kind of a couple parts to HCX, and um, it's definitely like Mohit said that there is a definite a whole session that can go along with that. So the HCX configuration will always require resolution of public IPs for updating itself and for checking its licensing. That's currently the way it is right now. Also, yes, if you're using a private IP address for Virtual Center, you do have to go in and manually edit the host file. Again, also something we know about and we're looking to fix. So, not much of an answer to the question there, unfortunately. We understand it, and it is something that we're definitely working in. So, currently, yes, if you're using HCX over Direct Connect with a private IP for vCenter, you will have to edit the host file on the HCX appliance, and it's something that we're continuing to work going forward. Is that a correct statement, Mohit?
Yes, yes. So either a host entry in the HCX manager on premises, or what you can do is like I talked about, creating a DNS zone for VMware VMC.com in the HLM slides. You can do something similar. Normally, so if you're not just using HCX, you're using HLM, you're using site recovery, and your the on-premises DNS server is not able to resolve public FQDNs. I have seen customers, they create forward lookup zones and reverse lookup zones for VMware VMC.com. So once you do that, you don't need to worry about anything else. You just need to create a host record pointing to the private IP of the HCX manager, and then everything will work. But yes, as Matt said, going forward, maybe in the future releases, we'll try and address this problem. So I'll move to cross VPC communication. So every SDDC must be cross-linked to a VPC within the customer-owned AWS account. This cross-linking is possible using the cross account ENI feature of AWS, and it creates a connection between every host of the SDDC to a subnet within the cross-linked VPC. This crosslink provides the SDDC with a network forwarding path to services maintained within the customer-owned AWS account. So say you have VMs on your VMC SDDC, and they want to talk to uh, an S3 bucket over a private IP or EC2 instances running on your AWS account. They can utilize this cross VPC link. It is a high bandwidth, low latency link, and can be used essentially for accessing any of the AWS native services.
Also free of charge. So all of the communication over this cross VPC link, sorry, is not charged, which is
Yes,
a good thing.
because your STDC is essentially deployed in the same region as your VPC, as your linked VPC. So there will be times when this communication may not work. In the subsequent slides, we'll discuss how to troubleshoot such issues. So, to better understand this, let's take up a scenario wherein an EC2 instance in the connected VPC needs to talk to a VM on the VMC HDC. There are various things we can check to ensure this communication happens. First, we'll start with the compute gateway firewall rule. What you are seeing here is a sample firewall config from a lab. Connected VPC prefix is a system defined workload group in here. This includes the connected VPC CIDR range. So when you create the SDDCs, this group will already be created and it will already have the linked VPC CIDR range. If you notice in here in the applied to section, uh, I have chosen the VPC interface. So this is an interface on the tier 0 router dedicated for the cross VPC traffic. So once we have verified that the the compute gateway firewall rules for the cross VPC communication have been set properly, the next thing is to check the security groups uh, on your AWS side. So security groups are like firewalls in the AWS world. Ensure that the security group attached to the cross ENI and the ANI on the EC2 instance has all the necessary ports allowed for communication. So say if you just want to test ping, you need to allow communication for ICMP protocol in the security group. So you would click on inbound rules, outbound rules, and ensure that you have ICMP allowed there. So I'll reiterate just once because it's really important. Uh, you need There are 2 points where you need to ensure the security group. One is on the cross ENI, and the other is on the ENI attached to the EC2 instance. So in here, I'll talk how can you identify which is the cross ENI which is being used. This is a little tricky step, so try and pay a little attention here. Uh, to give you a little background on this, tier 0 router on the SDDC, which is responsible for all north-south traffic, is deployed in an HA configuration. So the active edge resides on an ESXi host, and that ESXi host has a corresponding cross ENI attached to it. This cross ENI is responsible for all the cross VPC communication. So there are a couple of ways how you can identify which is that cross ENI. So the first is by the description of the ENI. It is like something like VMware VMC interface, do not delete. You see in here. Then, but you will see 17 of these interfaces. So how will you identify which one is the cross ENI? So only the ENI which has this active edge running on it will show up as in use and will have a secondary private IP address. So if if all three criteria, like it should be status shows as in use, you have a secondary private IP, and it is an ENI created by PMC. That ENI, you can note down the ENI interface ID, and that ENI is being used for the cross VPC communication. This step is not there in the documents because normally the customers do not have to worry about it. It is only when we troubleshoot these things is when we have to pay attention
And
to.
just to clarify as well, is that can change, right?
Yes, so as I said, uh, say you have bunch of ESXi hosts on your SDDC, and this cross ENI, which shows as in use, will be from is mapped to an ESXi host uh, is on which the active edge is running. So say you the you know the active edge vMotions from one host to the other. So this ENI ID will change, and one of the other 17 ENIs will be used. So you don't need to worry about the whole process. Once that happens, you just come here again and you would see another ENI which will show as in use, and it will have another ENI will have the secondary private IP address. So then comes the main route table. This is the route table associated with the linked VPC, and every time a new network segment is added in VMC, a corresponding route entry is added to this main route table. So this is how the subnets in the linked VPC know the path to route traffic destined for the VMC VMs. So ensure that all subnets within the linked VPC are associated with this route table. Otherwise, those subnets will not know where to route the VMC traffic to. It is also important to note that there should be route entries corresponding to the VMC network segments. If you observe closely this ENI ID here, this is the same one as in the previous slide. That is the ENI associated with the host where the active edge resides. So basically, on the left hand side here, these are the network segments I have created on my VMC STDC, and your AWS route table, the main route table, is telling the all the subnets associated with it to route any traffic to these networks through this ENI. So as Matt pointed out earlier, what will happen is, these ENIs can change. So ensure you are always using the main route table, because currently we only update the main route table. So say you have a subnet which is associated to a route table which is not this main route table, it will not get all the changes which happen on the STDC. So the ENI which changes, that will not be propagated to any other route table than other than the main route table. So ensure you have this taken care of. Again, this is I don't think so it is documented in any of our public facing documentation, so maybe you can keep this handy for any cross VPC communication errors you may find. This concludes my presentation for today. Any questions? I'll be happy to answer.
Yeah, I don't see any right now. Just wanted to throw in another quick advertisement for our videos. Is that Aiden Dalgleish and our team did do a webinar as well on the configuring AWS services with SDDC. If people want to go deeper into that, that's also available on our YouTube. But I think this is a fantastic troubleshooting overview and common things to look at. You definitely hit a lot of the points that I see our customers hit. So I think you're spot on, absolutely in it. We do have time. I know we're a little bit of overtime right now, but definitely if there are any questions out there, you could definitely ask us now. I believe there's a poll that they always want me to do, and I don't know if I can find it here. I appreciate everybody showing up. We will have a office hour session for the APJ time zones. It's going to be 10 a.m. AEDT, so Australian Daylight Time. I believe you guys have adjusted your clocks as well on Thursday. We run that every Thursday. We run these webinars every 2 weeks. And we alternate between this time and then 8 o'clock in the morning Pacific time for the EMEA / America's audience as well. We may be expanding on that. We're always open for suggestions, comments, anything you guys want to see in the future. Absolutely let us know. Again, if you're watching this recording on YouTube, or if you're watching it live and have some questions later, feel free to either hit me up on Twitter at vcloudmatt or email us at cloudcs@vmware.com, and we will answer them. And again, feedback is extremely welcome. But other than that, I guess if there are no more questions, I think we can call it quits. And I think I really do thank you, Mohit, for jumping in and putting all this content together himself. So this was, again, an extremely good overview of the most common things that we've seen. and hopefully people can watch this before they open up that chat support and maybe solve some issues before they even start, which is kind of what we really aim to do by these. So thank you very much, and look forward to seeing everybody in the future.
Thank you, Matt. Bye, guys.